Hey, genius, we're developing this idea where 7 to the k, with k being any real number, is a group. Because it's closed, 7 to the a times 7 to the b equals 7 to the a plus b, where a plus b is another real number, which is allowed to be an exponent, right? Everything has an inverse. So, for example, the inverse of 7 to the a is 7 to the negative a. The inverse of 7 squared is 7 to the negative 2, and that gives me 1, which is the multiplicative identity, which must be 7 to the 0. Okay, now what about fractional powers? How do fractional powers work? So if I take half of 7 and I add another half of 7, I must have 7. That's that's for sure, right? If I multiply by 7 half a time, and I multiply by 7 another 1/2 of a time, it would stand to reason that that should be the same as multiplying by 7 exactly once. So therefore, 7 to the 1/2 power is exactly that number that when I take two of them and multiply them, I will have 7. So that a squared equals 7, and we say then that a is the square root of 7. So a is the square root of 7, and that works like that. What about 7 to something like the 5/4? Well, that's multiplying by 7 once, and then multiplying by 7 one more fourth of a time, right? And if I were to do this 4 times, if I were to do this 4 times, let's think about that. 7 to the 5/4, 7 to the 5/4, 7 to the 5/4, and 7 to the 5/4. So I must be multiplying by 7 once, 4 times, so 4 times, and then multiplying by 7 1/4 of a time, also 4 times, because they're all interchangeable, right? So like 7 to the 1, 7 to the 1/4, we could switch places, right? That's how multiplication works. It's commutative. That's another interesting property here. AB equals BA, meaning A times B equals B times A. So this is the commutative property of an operation. Anyway, so I have 7 to the 5/4, and I'm doing it 4 times. That's 7 to the 1 to the 4, and 7 to the 1/4 to the 4. Okay, so if I multiply by 7 4 times, I should have 7 to the 4th. If I multiply by 7 to the 1/4, meaning I multiply by 7 1/4 of a time, but I do that 4 times, that's equivalent to multiplying by 7 one whole time. So this should be 7 to the 5th. And now we're starting to understand why 7 to the a to the power b equals 7 to the ab, because that's what happened here. We can also do this in a slightly simpler way without those fractions. 7 squared to the 3rd power. That just means I take two 7s and I multiply them. That's 7 squared. And then I do that 3 times and I multiply all of that. That is 777,777. Just kidding. It's 7 times 7 times 7 times 7 times 7 times 7, which should be 7 to the 6th power, which it is. Okay, follow for more.